Welcome back to r2con 2021. This is the third day. I hope you can watch all the streams from the previous days. So yeah, I think that volume is correct now. Sorry for the waiting. I was doing some checks for the streaming. So yeah, let's begin.
Hello r2con, this is Unix Freaks JP. Would like to make a presentation about the debugging and bug fixing Rudder 2 in the r2con 2021 conference. And this presentation is about how we can support our Rudder community and development by doing a systematic process testing and bug fixing. And in this presentation, I'd like to share my experience in doing such activities, and this is the wrap up in the form of the presentation. Usually when I start any presentation, I wrote about this disclaimer that this is also about the share back knowledge to the fellow blue teams, especially in the Radar community, dealing with the bugs and how to handle them properly, and also helping with the test. Stock is non-operational with no attributions and written as educational basis. Contains the basic know-how of the Rudder tools for the related topics. And the material is based on the Rudder 2 organization research that we are doing, and there is no data nor information from the other speaker. Well, in the next slide, we will start about the introductions. First, this presentation, you are introduced to understand about the development cycle of the Rudder team and how the testing and bug fix playing a big roles in it. And it will be explained also about how to handle the situation with the bugs and the handling of the Rudder 2. And this is merely from my experience in doing such activities. So this is about myself, as usual. So recently I'm doing the pretty much of the testing in the Rudder platforms to help the development teams to make more stable and systematic updating and versioning and so on. You can read about this explanation later on. And moving to the next slides, pretty much talks about the Rudder environments in the previous presentation that I have in several conferences. These are the list for them, so if you want to see later on, this is a reference for you. So we go to the why the testing is needed, and then why testing is needed and how. Testing is an important step for the stable release versions in the Rudder 2 development. Rudder 2 development is defined by the set of the milestones, and each milestone explaining new base of features to be implemented in the next release, and those base to be added with more and more features as long as the development for that base is continued, while in the development the new gems and the new planning for the next milestone is actually planned and to be formed to the next milestones to go. So for index example, the latest Rudder 2 versions, 5 versions, and it has been developed by the additional features 4 times, hence the minor version is a version 4, and has been maintained for the bug fix like 2 times since the minor version release. So this version means that it has the version major 5 and minor 4, and we had 2 times overall testing for the products for these minor versions. So that is exactly where the testing are doing the job. In this slide, we will talk about the requirement for the testing is supported to the many of the operating systems. So we have to be careful in picking which kind of the target for the testing that can support the development and can actually pinching anyone with a skill set that's capable to do so. And next, the time is needed. For the humans, especially because of the CI, it's not taking so much time for the making results, not as much as what the human does. So I will explain in details about how the human resource doing the time for the testing in this breakdown. So for the generic platforms like the servers and the commonly used desktops, overall doing the test for the new release is taking about the 1 day, like a non-stop testing for the whole days, and then you can drop to sleep later on in the next days. And it is supporting with Intel base or AMD bases. We can support with Windows, OS X, and Linux platform for that CPUs, and thing will take like a whole day to do so because of the embedded platform here. Embedded platform CPU is very slow, so mostly I'm doing that with the barebone devices, and maybe 1 CPU per day is the maximum speed that I can take time for doing so. And lastly, where there is a bug fix that needed to be done in the any kind of the support that described above, especially where for the CI is you can see the report is going like this, is quite details, and in this screenshot you can see the report of the CI result, which is using the integration with the GitHub, and it is having the Mason base for the building the packages, and these are the result for the one test scheme. And in the testing with CI, there is a merit and there is also demerits for them. And for the merit, is a really faster check, and it is integrated to the development environment, for example the GitHub or any kind of the Gits or others, and it has the automation testing in the every or after merge of the new code, and useful for the developer to instantly check or adjusting their works with a trial and error, so that fast, and then you can almost doing the checks for the either the build is gonna be successful or not almost in the real time. And the demerit for that is first, it's supporting only a limited specific build environment configuration of the platform only. So if you are having like one OS with having multiple ways to set up the build environments, probably you have to set that one OS with multiple ways also, and that means that you have to prepare multiple CI environment for doing so. And due to the supported and unsupported kind of the build method, missing CI are missing mostly the build bugs. There is also another factors that developers tends to not maintaining their CI distribution much, and since they have to prepare so many CI, and there are probably too limited devices to support those CI environments, and probably some human is, for example, like this can write POCs, can explain about how the bug is actually happen, and then can propose about the fix in the some kind of the proposals, and etc etc. So let's break down about what the human can do with the merit and demerit like this. The merit is a human can make a thorough check than a CI does. And a person with many skill set probably can support many kind of the platform to check. So the only problem is resources and time for him to do that. The second is human resources can build a team to check with bigger test platform resources, the bigger scope of tests that can be performed. So it can be delegated test works, and supporting to the many platforms to be maintained at almost the same times if the resource is big enough. So CI can do the same stuff too, but I don't think that they can doing parallel like 4 operating system in the same time. And human can cover testing for build, bug fixes, and troubleshooting too, and we will explain later on in the next slides. And the next one is a human capable to do quality control or the quality assurance of the stable versions after doing the thorough checks and thorough testings, and then having no bugs or no regressions that being spotted. The demerit for that is it needs so much dedications, resource, skill set is needed too, and time. Time is as per explained in the previous slide. And testing by the human resources cannot be done instantly and needs a regularly planned in order to make a delegations and the coordination. So needed to be planned exactly, strategically about the how, when, and where to make testing for the following the development process. So in this slide, I will try to explain to you about one of the strategy that I am doing in the order to performing test process of following the r2 major version 5 so far. So I made a kind of the alert bugs in another vectors of the either the platforms or the architectures and so on, and then the alert 3 is the place where I have to do the overall test of the products again. And this is actually implemented in the version 5, and you can see the details based on this release versions of the r2 from the version 5. It has the recent one is a 5.4.2, and we are starting this session from the version 5.0.0. And the roadmap for the stability and the portability in the r2 version until the 5.4.0 it goes like this in the testing circumstances. So the version release 5 is happening, and then I tag this as this color with alert 1. Let the development do the stuff for the improving and making plans for the additional features. And then when the release version of the 5.1 exists, the feature additional stuff was added to the project, and I also raised the alert 2 since there are plenty of the features that can affect other kind of the platforms users too. And when the 5.2.0 release and there is no testing was going on until that point, so I was performing the test for these versions. And it came up with a 5.2.1 which was actually stable, and it has a bug fix related result from the several tests that Pancake is doing many works too for the testing, and the full result is becoming the stable version of the 5.2.1. And again, new additional feature was developed and released, and I raised again the alert to be in this time is straight to the alert 2 because of there are some sensitive platform that actually being touched that time was making a bug for the other platform. Then we made another testing for that, and the result is the version of the 5.3.1, which is quite stable, and it has no bug anymore and all clear at the time. There's some kind of the changes there, and then so we think it is needed to perform stable at that time, but the one platforms cannot be pinned as quick as other platforms, so we leave it to the Git for that under decision of the Pancake. And The development for fixing the one leftover platform is continue, and the 5 point when the actual test that can be performed. The strategy looks work in this rather to major version 5, so I think it will be good for the reference for the future too. So the next slide is about the operating system used in the test. So the supported operating system for the generic platforms are we are using OS X, Linux, BSD basis, Windows, Android, and iOS. In this case, you have to ask Pancake for that. And which is the supported OS versions are long-term supported operating systems, and we don't test unsupported operating systems anymore. And then the specific device or distributions that is having a specific operating systems can be supported too separately with a dedicated maintainer if the maintainer is exist. And for example, like Game Boy React OS, Sergey Linux, Linux Hobbyist with exotic CPUs like Arduino and so on. CPU architecture. So in this case, I'm focusing for the most commonly used like Intel, AMD, ARM, MIPS, PPC, and Windows. And most of them are supporting in the 32 and the 64 bits of platform of the CPUs. We are also doing the extension test for the ARM M1 supporting the new OS X, and then we are having many kind of the experiment with the ARM, and currently we are, well, actually I have some boxes of the Cortex and Kirkwood running with several operating system installed, so it is done in that environments too. And then also, well, me and Pancake is having Solaris, so we are doing that separately. In this case, is doing some custom versions on the bug, and can be in one platforms or overall platforms that are supporting and can be installed with the Radar with the common installation methods. And we are doing in the recent version 5, we are doing the stability and portability test, which is actually started from the 4.5. And it is really pointing to the compatibility on the OS architecture and the devices. And for the devices, it will be case-by-case matters. And this is actually quite new. Is still under experiment or development, which is the backup and restore for features of the testing environments that we are having. And probably it will be a very good ways to be implemented as a plugin or as a one of the main features in the Radar 2. We'll see about that. Now, dealing with the R2 plugins, there are two kind of the plugins here, which is one is actually plugins integrated with the Radar source code and actually compile together with a Radar package, with for example like compressions, plugins, and so on. And those are also RTPM. So you have to understand, but have to know also about how to back up your plugins. And for more information about how plugin is integrated to the Radar core components, you have to seek those informations too before you are understanding about how to pin the bug. So in that case, you will need the information about the plugin, which is written in the R2 book, and that can be accessed online, or you can see the reference in this slide later on. Okay, we are here in the practical test, and it has two items. First is explaining about how to know the limitations of the Radar 2 and its environment, so we can actually differ which one is bug and which one is not for the tester. And then the other one is testing in action, so we will pick one case study for the testing. In this case, probably I will pick about the build test for understand it. So you have to be careful with the stuff like in the debugging, for example, several systems just doesn't support the software breakpoints, instead using the hardware breakpoints, especially where you are dealing with much of the embedded or IoT devices. And some CPU probably have limit for the usage of the hardware breakpoints. For example, in the Intel platforms, it has 4 breakpoints for the hardware that can be used, and that is a very important details that you have to understand beforehand. Written, especially when you are in the middle of the debugging something. And it has also with the emulation like ASIL. So for example, you cannot force ASIL to go backwards without setting the initiation of the starting point for the VM of the ASIL to start. So that is one tips that one stuff that you need to understand. And not only about the analysis, but in the plugins also there are several limitations that you have to understand too. For example, in the R2Deck plugin, you cannot run PDD on non-Intel platforms like MIPS, for example, or PPCs, because of it's just not supported for that platforms. And for the R2Ghidra, you just have to install R2Ghidra integration with the Radar PM, or else well, you can compile the Ghidra, probably you cannot make it integrated with the Radar 2 if you don't set it properly, because of the integrations is quite demonstrations. First is about the build test. The build test, probably we will pick either a system-wide installation or use space. Probably I'm using system-wide mostly for the test, so probably I'm gonna just doing that in the FreeBSD environment, architecture binaries, and debugging, invoking about how it is started with the -d or OODs, and lastly we'll do some testing of the ASIL, and let's see whether can be performed quite well. And also there is test build reporting that I would like to giving several examples for the reporting purpose. It will be shown in the screen after the testing stuff has been done. So let's get it done. So always refer to the Radar.org GitHub pages for the downloading of the new release version. So all you have to do is go to the which version that has been released, latest versions, and scroll down to found the assets, and found the source code for the installation, for example in this one. So after you pick the source code, you can download it to your installation platforms. In this case, I'll do the FreeBSD thing for this one, and it is using the 12.2 version, which is actually currently are still listing, yeah, until the end of March next year. So it's quite good for doing the test. Then after the version is supported, and we can just start to download about the package of the source code that we saw before in the GitHub of the Radar. And all you have to do next is just extract the out of the box. There you go, it will be extracted just as per it is, and all you have to do is well, in my case, I'd like to make sure this is a release version, so I just rename this into kind of the BSD ways like this, and I just go to this directories, and just first I have to make sure whether this version has the previous rudder or not. So it has the previous version, so all we have to do right now is try to get rid of it by uninstalling the previous version first. Okay, so the FreeBSD, you have to really make sure that to use the gmake instead of the clang make to do the installation and uninstallation script. So in this case, we will do the gmake for the uninstall or install or purging rather packages installation of the new one. After you uninstall and purge the previous version, so you are very good to do the installation for the latest versions. So all you have to do is you go to the main directories of the where the makefile and the configure file are there, and over there all you have to do is just write the one command, and if the sudo are set well in your machines, and you will let the rather using that SUD for the installing the specific path for the library purpose. So all you have to do is just run this command like this. There we go. This is actually the summary about what being installed right now. It is showing the version of the 5.4.2. So here we go, the installation is starting. The compilation preparations is being start here. So I will pause the process so we can just skip it until the end of the this building process. There are several warning there that probably came up, so you don't have to worry about that as long as the error doesn't came up. Okay, it looks like the installation that has been done. So if you are seeing the messages like this, meaning that the installation that has been done successfully. So all you have to do depends on your flavor of the TTY. You can copy paste about what has been recorded in the screen, or you can also pipe what every STD out of the message that the generated during the compilation process. So after you manage to get the installation log, this is actually contains the information that you will need to report if there is a bug is going on, or something's happened that is not as per plan. So in this example, this part, which is we can see the one with the final report is a very important one, which is explaining you about what kind of the installations and what kind of the stuff that actually being installed and being detected running to your system right now. And if you are having a problem, please attach this report, or at least this final report is quite important for the developer teams to actually study about how the system is installed. And there is also other part which is explaining about the building environment, and it is having another final report over here. It is explaining about what compiler that you are using, and so on and so on. Then the installation is running, and in this case the capstone is installed first, being compiled here, and then the components of the router will be installed afterwards. So this is actually the source code that being fetched and used for the compilations, which is having the main path of the library where the rotary source code is actually being placed. And these are the final compilation stages, which is generating the binary for the rotary use. And as you can see, most of the operations are using the gmake here, not using the make. The concept is using the ACR for the installations, and in the end the package is being installed and placed successfully. So since we are okay with the installation, so let's try it with some basic tests that to check whether this version is actually ready to use or not. So some basic operations can be used for this purpose. In example, well, first you want to be sure about the versions of the rotary stuff that you're using, and then let's see about the plugin components too. Well, we don't have a miss about that, and now we are having this. Then probably we would like to try to load some binary for the test. In BSD we have the test binary like this, and check about the whether the architecture and every detections are in the right place. This is correct, and we are having the FreeBSD running here with the AMDs, no problem. And after that we can start with some several basic analysis. For example, sometimes it crashes in the previous versions. We can see about the analyzing about the symbols, and let's check whether the symbols are actually being fetched properly. You can compare this result with another tools like object dump or redelf or any kind of the tools that can confirm but the reading of the imports or export here are correct or not. And we can increase about the analysis level, and let's see about the function list, stuff like that. This is quite important if we are going to use the analysis for the radar. And let's start with these functions. It is printed quite well. For example, let's see with PDSF command, it can show the string quite well. So currently we are in here, I guess. No, not exactly. We are in here, so we may want to check some basic functions like PDC, for example. It has the PDCO that can help people to analyze some assemblies at some points. There are many ways that you want to check, for example, the dumping commands, and then the search, and search or seek or history, whether recorded or not, and check interactions to the cell. For example, let's check about the it runs very good, and let's see it here, and let's see, for example, you are analyzing some kind of functions and like this, and probably after you analyze, so you want to PDF, and you want to check the grep, whether it's having the move commands, stuff like that. And there are many ways that you can do for the testing, like dumping with this result to another text files. For example, it's a ATXT, and you want to just write the ATXT here. It's showing the same stuff. So parsing is doing good so far. for the basic testings. Now we can check for the visual mode, starting with V commands, and you can see this is the one that we usually see, and we can see whether the tabs are working well or not. It shows the changing between the ASIL and the non-ASIL mode, so we can check whether the visual mode are working well with some command that is only supporting in it. For example, I want to just make a flag in here with the name of the testing one, and it's working. So let's say commenting to anywhere that I want to do, like okay, this one, like this is a push. Okay, it is working, so that is no problem so far. If you are pressing the O, it should show about the exchange between the ASIL and non-ASIL. It is working for this visual mode, and we can see the menu of the D for the analyzing something. For example, you want to change several blob into strings. It's just a matter of the parsing and reading, so you don't have to be worried so much about something being ruined. For example, I want to set this as a string, then it should looks like this. Well, let's destroy this one too. Okay, so we are making it a very horrible assembly now, and the functions are working just fine. So this is kind of the testing for the visual mode, and there are many tools in the visual mode that can be done too. For example, if you want to search something or you want to highlight something, and setting for the ASILs. Well, in this case, I'd like to return to the entry 0. So just making sure that I'm in the right place. Okay, here we are. Good. So in order to do the ASIL, I have to understand about the current state of the ASIL. I will use this command just to make sure that I'm not gonna ruin anything. So just checking, make sure the cache is being set, and the setting for the ASIL can be seen here. It is set to the true and true because of we are playing with the now we can check some several operations of the standard ASIL, like for example this command. This is actually the standard operators for the ASIL, so it's working pretty well. And probably we will try to start the ASIL for the virtual machine to start at the initiated and starting from this point, and then probably we would like to, let's check like this. It's supposed to be moving. Oops. Habit dies hard. Okay. It is going to the it goes to 1, 2, and right now it's in here I think 3 times. So let's make sure that with the history command, so this is a 1, 2, and 3. So that was why I'm here right now, like from here 1, 2, and 3. Okay, good, great, it works. So Let's check about the say I just want to go here, so in the ACL it's supposed to be like this, and let's see. Okay, it works. Stepping is working, so I don't need this EAP anymore, and let's turn it off. Then probably the ACL is working quite well, unless you want to make it further check, like just want to make sure about the IO cache, whether is it still on. True. So let's write about the so stuff like that is supposed to be written there. So let's see whether yep, the repe command is actually came up. So let's see about the what ACL says about this. Okay, I don't think there is a problem at all with the ACL until this point. I'm not so sure. Probably Conrad can do the more testing than me for the ACL parts, but from my point of view, there is no problem with the ACL engine in this version, this platform. So how about the debugging? Debugging can be done instantly, like if you are turning this into OOD commands, and you can check directly to the memory after this, and let's see whether the reading is going as per expected. I think the assembly setting is a little bit weird, so let's make sure. Oops, it is a 64. Oh, it has the register of the 32 bits here. We are actually, you are in the first one. This one is in the also the first one. Everything is in the first one. This is actually the current existing program, so no, this is not good. Stuck is crashed. Yeah, so it's supposed to run like that. So I don't think there is a problem with the debugging for this version, so can be considered as a unbuggy version. That was why it was set as a stable version. So it looks like it has no flaw at all in the any confirmation that we were doing with these versions. So we done the interface static analysis test, debugging test, and the ACL test, and we have a good reporting details with this, that it should be saved somewhere as a reference for us for in case there is a new features being added and we want to compare. So this is it for demonstration of the building for this chapter, and there are several build examples that I'd like to show you. In this case is using the Debian stretch for the Raspbian of the ARM 64 devices. And you can see it here. These are the configuration. It was running well. Collecting stuff like this for the exotic CPU is quite one of the good preference for many kind of the setup in the IoT devices or the embedded environment. This one is for the ARM HF installations, so all of the information is there, the processes, and then the installations, what was detected and so on, and this actually being recorded for the development checks and errors that can be used for the reference for the future. So let's go to the next chapter. Oh yeah, before I forgot, there is things that I'd like to explain first. Well, this is the memo that I made around January this year when